Good day to you from Anagalactic on this first day of March. Over here you see a geometric image. We are currently proceeding through a geometric proof sequence. What would be the purpose of doing such a thing? We are attempting to get to the basis of geometry, which will entail getting to the basis of our computational system, which of course is based in geometry. We were all taught this, the Euclidean geometry. The reason I paused at the qualifier Euclidean is that there is a whole list of Euclidean nominatives. The Euclidean plane, the Euclidean line, the Euclidean point, Euclidean geometry, and although I have not seen the term Euclidean mathematics, you could compose such a compound word, Euclidean mathematics. And in fact, as we have shown thus far in our sequence, which if you haven't tuned in till now, don't worry because I always keep my presentations self-contained. So welcome to Anagalactic. If this is your first experience here, the fact that I've stated that we are in a series may put you on your guard that maybe you've missed something. Well, of course, I make all these videos for a reason, but I have made 1,500 videos. The topic that I cover is called geometry, and geometry is a most fascinating topic, beginning with what is it? What is geometry? Now over here you see a diagram depicting what I would say most people would agree that looks like geometry. Why? Why does it look like geometry? There are two reasons for stating why you think that from this explicit diagram, not trying to generalize to any other situation, but looking at that. If you were to say, well, that looks like a geometric diagram, or that has something to do with geometry, and you were challenged, and someone just provoked you, perhaps to find out more of what you know, or to drag you down and make you look foolish. Well, there are those two frames of mind for questions, but you may simply want to be doing science the way it's done, which entails asking questions, because we're trying to get understanding. And so why is that geometry? If you were forced, it's like there's some kind of password thing, and it's like, oh yeah? Look at this diagram here. It's showing you this. What does that look like to you? Does that look like geometry? And you're like, whoa. Well, yes, it does. Why? Why does that look like geometry? Otherwise, they're not going to let you in. Okay. And you want to go in for whatever reason. This could be many different kinds of story to back this whole scenario. But now you're forced. And now you have to like say something like, why the hell do I think that's geometry? And you have to ask yourself, what is geometry such that I would make such a bald statement that I would just say, oh, it's like being asked, do you believe in God? And now it's like, Jesus Christ, I have to answer this, but you don't know why they're asking you this. You want to go in here? Really? You want us to let you through that door? Well, let's just make sure of something first. Do you believe in God? Do this. But in this case, it's the same sort of thing, only they're showing you this. It's like, hey, what does that look like to you, bub, who wants to go into our building or whatever? Does that look, and you're like, what? Well, if I gave you some choices, like, does that look like mathematics? Does it look like construction? Does it look like finger painting? Or does it look like geometry? And they're looking at you, everyone's looking at you. One guy's kind of got his hand near his gun or his mace or whatever they have to protect the entrance, and you're trying to get in. And now this is your test question. Why do you think that looks like geometry? And now you've got to answer. It's like this is the harshest exam question you have ever faced. And now all of your ancient fears and insecurities just are rising like bile in your throat as you stumble and you doubt yourself. Why indeed do I think that that's geometry? Well, we dealt with that in the last video, and if you didn't see that, then gee whiz, man. Go back and watch my previous 1,000 videos. I don't know why you think you're going to understand this. So the reason is that there are lines, and we carefully defined what is a line, so if you missed that, I'm so sorry, but this is just going to be pure gobbledygook to you. Because in the last video, I finally defined for the first time in human history correctly what is a line. You'll see that there are two kinds of line. Let's just make this simple, right? Science is simple. That was in the last video too. So really, if you missed the last video, I pity you. So I'm just having a little bit of brunch to try to wake up. You notice I'm wearing gloves. These are actually anti-carpal syndrome gloves. But I thought I should explain why I have these peculiar looking gloves. These are a godsend. But I can do this now without wincing. And this is because it snowed last week. There's nothing spectacular on this diagram at face value. But what is it? Well, it's a plane. So there's one object already, and this is important in my approach to geometry, is what is the primary object. That's called a space. So this is planar space. And what that means is exactly what every single human being agrees and knows and is born knowing, is there is such a human mental construct as a flat surface. But to call it a surface is actually an abuse of the word surface. The only reason we call it a surface is because we can see it. You can see a plane. So that is the primary object. Now, our objective in my approach to geometry is first of all to begin exactly this way. And so I just did. But now what is our goal? Our goal is to understand everything worth knowing about the plane. And there are profound reasons for wanting to do that. It has been proved in the branch science known as physiology that is how we see a plane. That is what we see. So there is an interesting factoid, is what you see. You're always tempted to say is what you get. Is what you see what you get? That is being debated at the highest levels of science right now, and always has been. So instantly we are introduced to some of the most ancient and vexing philosophical questions that go right to science. It's not religious philosophy, unless you include rational logic as perhaps forming its own religion. And I've never thought of it that way, but there's a better classificational system whereby you can very conveniently distinguish between religion and science. However, it is extremely important to know the similarities between those two systems of addressing the environment. Yes, the environment. We are so used to using the word universe. The word universe came into vogue about the time that it did, because things come into vogue on a spectrum of time, because there's a rise in vogue. But the word universe is as old as the universe. Mankind has been considering every question discussed today forever. None of these questions are new at the level of which I speak, which includes geometry. What is it? Well, if you look at this case example of what I would definitely call geometry, my answer to the question, why do I think that that's geometry? It's because it has lines. But the reason that it has lines has a cause. It's not a mechanical cause and effect cause. It's a structural prerequisite. In order to have lines, there must be a space for the lines, and that is a technically accurate definition of a space in geometry. Very important. That is a geometric use of the word space. You will find that point, line, space, and several related words going into categories of words have numerous distinct meanings. But when it comes to the most weird word, I would choose either point or line, but they all qualify as having something weird about them. But for my money, line. Now, do you capitalize it or is it lowercase? Those are two different words. If you know how to use capitalization effectively. So capital L-I-N-E, are all the lines on that page? No. That's lowercase. Lowercase L-I-N-E. Everything on that page is a line. Oh, did I make a mistake? The professor may need to apologize. This is the right time to ask a question. If it's bugging you, which it should, what about the O and the 3 digits? What about the alpha character and the 3 numeric glyphs? Are those part of geometry? Don't answer too hastily. There are different flavors of questions, and the question may contain hidden prerequisites for giving an accurate answer to the question. Some questions are trick. They're trick, which has more than one meaning, and trick is a most interesting word to study. In the most general superclass definition of a line, the definition that I say of a line is anything you can draw without lifting from the surface. And that would include a circle, that would include a line. It would include any letter in any alphabet, unless the letters are, as in Chinese, separate strokes. But if you include the separate strokes and the concept of character, which is already the definition, so I'm just saying what it is, a character has nothing to do with whether you can lift from the surface or not. But in the definition of a line, I say you cannot lift the instrument of writing from the surface of writing. And this is writing. And there are some glyphs. Those glyphs could be classified as a kind of line. I do not. But I begin in the superclass by including them, because then the concept of a line is extended. However, it's not an extension of geometry. It's an extension of nomenclature. It's an extension of something we shouldn't worry about too much, but I make it my job to worry about critical distinctions at the axiomatic level. The point is something very interesting to try to define. But for my money, if I had to choose from a multiple choice and I can only choose one, if I had to choose what is the most geometrically central idea, first of all, the object, because the plane is an object. So that defines the space, which is the surface of geometry in that space, which here is a plane. So the plane is the axiomatic basis of rational science. The plane is. However, if I were just a little bit too adamant about saying that, I might forget the primary lesson to be learned from the principle of superpositionality logic. The principle of superpositional logic is that you can never make a statement that is complete unless it is a compound dualistic statement, which means you're going to have to say two things before you can say one thing. And that is actually a step backward, which gives some people, including I think all of us when we think about it, an uneasy feeling. Is you don't want to be stepping backward if you're trying to get onto a solution vector. Because the predicate of science itself is that you have a problem that you want to solve. And if you're not doing that, you're not actually doing science, when science is defined as being goal-oriented. Goal-oriented. We know the definition of the goal. It's the solution. The solution to a problem. And that's where geometry begins to show up at the basis of all science, because science is about solutions, and you have a finite set of problems which are defined as problems. And the definition of a problem is some question that you must answer or you're fucked. You have questions that must be answered. And so you're looking for the answer. And that means that you have to have a very, very draconian definition of a logical question. Is your question logical? If it is, you can prove it using geometry. And that goes to the basis of rational logic. What does it mean to be rational? It means you have two quantities in relation, because you cannot live in geometry without at least some of those numbers beginning at 1, going to 2, which is a much different concept than 1. And when you go to 3, you learn to skip that number. 3 is not a fully computable number. 3 is not. The digit representing that number that you see, to answer our original question, part of geometry, yes, no. It's hierarchical.
3! We all know what it is! Do we? What is it?
First of all, it's a line. It's not a geometric line. It's a symbol. So a circle is a line. Yes, and that's final. That is a proof sequence. The circle is a line, but the 3, the 2, the 1, and the italic O for origin are not lines. They can be drawn, but that does not make it a line. What makes a line is curvature. Curvature makes a line. And that's the only definition of a line. And you have one special case of that. And now we will classify the line. In the superset, which is the predicate set, which is a unique superset, it's the meta superset. The meta superset class of line includes anything that you can draw, including a Chinese character. Anything that you can draw at least consists of lines, but those are not, repeat, not, repeat, capital not, lines. In geometry, we change that definition to something much more specific. This is an object that you can see, an object that you can see in a space. And now we must define what is a space and how does it relate to physical space. Physical space you can see as an absence. It's an absence. It's an absence of proximity. It's the antithesis of proximity. Okay, that is physical space. Physical space is the absence. You can use a symbol for that. 0. That would be the proper beginning of the universe using Euclidean geometry. The universe is a point to the proportion that it has space. Space is the absence. Space is negative in a valence sense with reality. The only thing that we see that is not real is space. That statement that I just made has been disproved. That statement that I just made, that space is nullity. In a mathematical system, it would be 0. The absence of whatever it is you're saying, it's the absence of that. 0 is the absence of a number, but a point is the absence of space. The absence of space is a phrase which you could turn into a term, and I'm going to capitalize every word. The capital absence of capital space. The absence of space is redundant. Space is the absence. If it were a number, it would be 0. So space is nullity. It is the absence. Is that true? Why would I even suggest that that might be true? It's because in space, there is neither matter nor energy, nor is there time, nor is there quantity, nor is there any definition of quantization or even of continuity. It simply is nothingness. It's absence. It's not negative, but you might say so. What's it the negative of? It's the negative of its negation. So space can now be defined. Physical space is the negation of its own negation. And that is the correct linear definition of the universe. That's the Euclidean definition of the universe, is that it is the absence of the inverse of absence. And so it is the reciprocal of 0. Is it? No. It's 0. But 0 has a reciprocal. That has a name. It's called reality. That's reality. It is not the universe, because the universe contains Zero. And that is the definition of space in terms of reality. So if you want to decide once and for all what is real, then restate your question precisely. Give an example. Is space real? Yes, because it's in the universe. But if it is, which I'm saying it definitely is, then the universe is valent. And 1/2 of what you call reality is anti-reality. You have to get the valence right. Which is real and which is unreal. Space is unreal. So space is linear zero equivalent. That means that what we call the universe has zero at the center. It's called space. And everything around space, which is nullity, is energy and matter and time. We have switched to our visualization of a sphere. You will see that the circle is actually tilted and it's in blue, and that's the equator of the sphere. There is a second circle, which is the outline of, as when you look at the full moon, what you see is a filled circle. And you see another circle, so there are two circles here in relationship. Can you identify the relationship between those two circles? You might guess, and you might guess correctly, but you also may want to pause and not answer the goddamn question at all because it's not being specific enough, and you'd be a fool to answer it. The great circle in blue, which is an ellipse, is drawn that way to show a rotated circle on this axis, correct? So as it rotates upward, you see a full circle, but as it rotates downward, it collapses to a straight line. So a circle on rotation from the correct orientation will appear to collapse into a different dimension, and that's profound. So that's the relationship between the great circle and the sphere in which it is embedded. So the circle is actually drawn on the sphere. So the sphere is the blackboard. That's called a surface. Just like a blackboard is a 2D surface, this is a different surface that not only has nothing to do with D, but introduces the concept of an actual surface. The actuality of a surface depends on what you're trying to draw. And if you're trying to draw a circle, you can rotate the circle so that it fits on a plane. But in this spherical projection, you'll see a second circle that's not even drawn as a circle. It's drawn as a perfect ellipse. And the definition of perfection here is that it creates the perfect illusion of depth. But it's rather automatic, because as you dial that blue circle forward and backward, right, it will eventually match the circumference, and that would be probably 90 degrees, depending on where you start your metric system. And you continue to rotate it, it'll rotate all the way around and again match the circle. And if you keep rotating it, you'll notice it goes in quarters. And that introduces the phases of the moon, which is based on the number 4, because of the natural divisions on the lunar surface, which is a sphere on which light is being drawn. And from a certain perspective in solar system space, you could look at the moon and not see exactly the same kind of phase change, but you would still see, perforce, physically, somehow, the phase change. But here, what you're seeing is a fixed circle that is perpendicular to the planar circular projection. So a circle affixed to a plane is the black line, and that has a geometry called an intrinsic geometry, the geometry of a surface. This takes the place of the hyperextended word manifold. Manifold. That's a poisoned word. It's okay in context, but when it's examined from an objective point of view, a mistake was made. And I'm just here to suggest you listen to me about this now so that you can correct your mistake. Otherwise, you're just going to continue without correcting it. So this great circle is orthogonal to the planar projection. And so those two circles, the blue one and the black one, are at right angle. Those are at right angle. You can prove from this very natural projection of a natural sphere, a basic sphere. All spheres are alike. You can't tell if that represents the universe or a quantum unit of something, which we're getting to. Of course, that is the quantum unit of something. But alas, with Euclid, you'll never, ever figure that out. Euclid will make sure that you never see that, because Euclid didn't see it. Euclid could not see this. That there is a basis to his use of the orthogonal function. It's a function. Orthogonality is actually a geometric relation, but whenever you use the Pythagorean theorem, you're using a function. That's a function. And a function causes a transform. What are you transforming? Have you ever thought about that? I'm only suggesting this goes deep quickly. But this is simple. It's simply the relationship between two circles. And this actually explicates in quite an interesting way the relationship between a sphere and its unique circle, which on Earth we call the equator. Well, every sphere is like the Earth. The sun has an equator also. And what is that equator? It's the integral of angular momentum on that object, in this case a physical object. Well, you can project that onto this geometric object. And so that great circle is the equator of a sphere. And now we want to more carefully define what we mean by equator. The technical term, which I very much enjoy, is eigencircle. And the reason the eigencircle is so important to name, so that you give it a name, is that it is the integral of angular momentum. It contains that quantity, is on that surface. A circle is a surface in 2D space. But when you say 2D space, what you're saying is that you need two computable numbers. You need two computable numbers for the plane. That's obvious. That's what we were taught by the second grade, is that if you're looking at a plane, which Euclid is, then what you need are two numbers. And what he proved is you can define one number on one part of the plane, and you can define the other number on the other aspect to the plane. And that's called 2D mathematics, which requires squared numbers. X squared plus y squared is how you end up being forced to solve that interesting mathematical problem. How do you use your linear numbers, which all exist on a line, to parameterize the plane? You need two lines, obviously. And that's called 2D geometry, 2D. So it's the geometry of the plane. No, you're not saying it right. It's the geometry of the plane when you force yourself to begin with linear numbers. But you don't need to force yourself to do that because there's a natural number system for the plane. And it has to be a composite of two linear numbers. That much is true. So that sounds like a paradox. Well, that paradox needed to be solved. I solved it. And the solution to that paradox is you compose the two aspects that are in fact linear numbers, but you simply put them into their natural relation when you don't start with a line. Well, you only have one choice if you don't start with a line, but now you need to be much more specific. And this is why I say, and I just violated my own principle, and you'll see in a moment why I say that, when you say line and you mean a straight line, you actually have to say so. Because I'm saying that a line is a circle. That's a line. The straight line is not a line unless you can prove it. You can, it's the derivative. Every circle has a diameter, and it turns out you can prove that that's a derivative of the surface. Is the diameter has a direct relationship with the surface. So those are two numbers that are in two different spaces. And that's a data type in this case. They're two different data types. The difference is that if you're just talking about a line, which is how Euclid began in Elements, you're just talking about a line, then you have one linear number. And that's quite an amazing and profound identity. Because if you do have a linear number, you're defining the presence of a line. So you're stuck with straight lines. Well, you shouldn't be. You can't be. You mustn't be. Because no lines are straight. All lines are circles. All lines are circles. So where did we get the notion of a straight line? Because that's really abnormal. That is abnormal, is to conceive of a straight line. It does not make sense until you can measure the distance to a star. We believe that we've been able to do that. And of course, I believe this is one of the most interestingly proved facts of all time, is that a straight line distance does exist simply on the basis of how you see a star. Because the star, by definition, is at a point of infinity. Essentially, it's infinitely far away for this reason. You can't see its magnitude and size. It just looks like a point. And you can increase your magnification on a star with any telescope you care to use. And it's going to take you until the late 20th century before you can even begin to see something like, as is now claimed, we see planets. You need to actually check that evidence. Oh, it's a rage. It's been a rage for decades. I saw it rise. Exoplanets.
Sure. I'm sure you did.
Are you absolutely sure? Oh, fuck, the artists go out of their minds for this stuff. Oh, I think it may be some people's personal goal to make shit up. How about a comedian? Are you just making shit up? Well, not the best. Guys like Chappelle, Carlin, Seinfeld, Cosby. He actually went on to make other really, in their own strange way, enviable achievements. And this is really stretching the matter. But he's a polymath with his body. He can live many lives. It doesn't matter to him. And so he actually is much more well known now for some of his other activities in his lifetime than comedy. So somebody somewhere way up high really hates the living fuck out of Bill Cosby's comedy, which proves to me the existence of the devil. And I may have actually seen the devil's face, although you want to forget. You're not sure, and then later it's like, fuck, that must have been the devil herself. The devil herself from Santa Cruz. And not naming names, it's more of a group entity. And does that have anything to do with the sphere and circle? No, but it has a lot to do with my brunch. Okay, then. So essentially, we're looking at two orthogonal lines. And I think that that's a brash and just notoriously arrogant. And the way I say it is like just slap it, just slap, 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 slap. I suppose I will see you on the jousting field then, won't I? How about right now? Just lunge! Just drag him down with a two-legger and just start ground and pound and pound. God, you can just smell the joke in there. If only I had the gift of comedy. Alas, children, we all pine away after the previous world, which could be the anti-world or the behind world, or it could be the future world, as many believe. But really, belief has nothing to do with it in this context. In terms of belief, either you're blessed or you're not. I'm sorry, but you're either one or the other, and you're not going to change. You're never going to change. Believers aren't going to change either. They're going to remain whatever it is that you, as an infidel, will never believe, because according to us, we are lost. Well, yeah. Well, most people are. But we're not. I think that's one way to approach religion. If there's any damning to be done, we are certain. We're looking at you. We're just looking right at you. Oh, yeah. There will be a lot of damned. And you just like start staring into the camera for the first time. Like it's a j'accuse. You are why we know about sin. You will be consumed. You have to go. We don't have the time, energy, strength, power, or will. But there's got to be something that takes care of your kind. Whatever you did we don't like, we've probably forgot. But we's never gonna forget. 'Cause who knows anything, my friend? And that is running up on 81 minutes, so that may be good enough for now. And I may not publish this, but I may listen to it. All right, we'll be right back. Thank you, you listeners. It means a lot that you tune in. I don't ask for money, but I'll tell you what, to get that like every now and then, that actually helps. All right, keep looking up. This is Antigalactic.